Welcome student on another video lecture. Topic is tracer technique. In that we have seen about the criteria for tracers, selection of tracer. Now what are the different steps of tracers technique that we are going to study. In that first one is preparation of label compound. Before preparation of label compound, the selection of radioactive tracer is done, and that selection of radioactive tracer is based upon the half-life of that radioactive isotope. So what is meant by radioactive tracer? When one or more atom of chemical compound they are replaced by radioisotope for the study of biosynthetic pathway is called as radioactive tracer. So one or more chemical compound that is replaced by radioactive isotope or radioisotope, and that will use to study biosynthetic pathway, they are known as radioactive tracer. These radioactive tracers they are the inorganic compound, and in the synthesis the purity of the product is of great importance. So small proportion of strongly radioactive impurity might seriously jeopardize the result of any subsequent experimentation. For that reason, in this synthesis, purity of the product is giving more importance. The compound should be pure and it should be less toxic. It will not create any serious toxicity. Second one is introduction of label compound in the biological system. Third one is separation and determination of label compound in various biochemical fractions at later time. Now preparation of label compound. Many compounds which are most conveniently prepared from natural sources. So these label compounds they are conveniently prepared from natural sources. For example, by growing chlorella in atmosphere containing 14 CO2. So that compound is prepared. That how that compound is prepared 14 CO by growing chlorella in an atmosphere which contains 14 CO2 14, and in that the chlorella will grow and all the carbon compounds of that organisms become labeled. All the carbon compounds become labeled. That chlorella which certain amino acids by hydrolysis of proteins are produced by growing chlorella in atmosphere containing 14 CO2. So if the atmosphere contains 40 CO2 and the chlorella is growing in that atmosphere, then certain amino acids are produced by hydrolysis of protein. Certain amino acids these are produced by hydrolysis of protein in presence of that chlorella in the atmosphere which contain 14 CO2, and all the carbon atoms in the organisms they are labeled and they are uniformly labeled. Each and every compound possessing a uniform labeling for its carbon atom. 3H label compound are commercially available. Tritium labeling is effective by catalytic exchange in aqueous media by hydrogenation of unsaturated compound with tritium gas. So 3H label compound, that is hydrogen 3 isotope, it is commercially available. After that tritium, how the tritium labeling is done? For tritium labeling in an aqueous media is taken and that organic compound is irradiated with tritium gas. Organic compound is placed in aqueous media. That organic compound is irradiated with tritium gas, and by hydrogenation of unsaturated compound with tritium gas, it will produce a tritium labeled compound. That tritium is a pure beta emitter of low toxicity and half-life is 12.43 years. half-life of tritium compound, which is prepared by irradiation of organic compound with tritium gas in aqueous media. It is a beta emitter. Beta radiations are emitted, and it is a pure beta emitter, and the half-life is also 12.43 years, and it is the compound is with very low toxicity, and radiation energy is lower than that of 14C. And third method is by use of organic synthesis, like Grignard reagent is used for organic synthesis of labeling compound. CH3 MgBr is a Grignard reagent which is react with 14CO2. It will produce CH3 14COO MgBr plus H2O. Then it will react with H2O. It will produce CH3 4COOH and MgOH Br. So these are the synthesis reaction, organic synthesis reaction of Grignard reagent, and in this way the label compounds are prepared. After preparation of label compound, now introduction of that label compound in the biological system. In that, first one is root feeding or stem feeding. These are the most common method, and selection of plant part is depend upon the site of biosynthesis of desired metabolites. So where that particular secondary metabolite gets synthesized, according to the site of synthesis, the plant part is selected. For example, root biosynthesis, example is tobacco alkaloids. Tobacco alkaloids, they are biosynthesized in the root. So root feeding method is selected for biosynthesis of or to trace the biosynthetic pathway of tobacco alkaloid. Stem biosynthesis, for example, latex and euphorbia. Here the latex is produced from the stem. The stem portion, cut the end of the stem. It is immersed in water, nutrient and radio labeled compound. So the stem is selected, and that stem cut portion is cut end is immersed in the water, nutrient and radio label compound, and in this way the stem feeding is done. Direct injection method is used for those plants which are having hollow stems. For example, those plants which comes under umbelliferae family, for example fennel, coriander, all these drugs they comes under umbelliferae family. In that direct injection method, is used directly. The radioisotope is injected, or in case of opium capsules, also the direct injection method is used for feeding. So according to the part where that particular secondary metabolite gets synthesized, different methods are selected for introduction of label compound. If the site is root, then root feeding method is used. If site is stem, then stem feeding method is used. In stem feeding, the cut portion of the stem is placed in water nutrient medium with radiolabel compound. After that, those plants which are having very hollow stem, in that case direct injection method is used, or the capsules, for example opium poppy capsules, the direct injection method is used. Beak feeding method, to carry out feeding on the plants rooted in soil or other support without disturbance to the root. Beak feeding is possible. So the plant is rooted in the soil and it is with other support, without disturbance to the root. Here root are not disturbed in case of beak feeding method, and in this method cotton strands are passed to the plant stem. Plant stems are selected and cotton strands are passed through the plant stem. The terminal end of that cotton strands are immersed in a reagent labeled with radioisotope. So the radioisotope which should be introduced, it is placed in the reagent, and that in that reagent the cotton strands are immersed, and in this way beak feeding of that radioisotope is done. After that, next method is floating method. When a small amount of material is available, leaf disc chopped leaves are made to float on the substrate solution. That substrate solution contains radioactive isotope. So that in that substrate solution, radioactive isotope is there, the label compound, and the leaf disc or chopped leaves, they are float on that substrate solution which contain radioactive isotope, and in this way introduction of radioactive isotope is done in the leaf or leaves. Now spray method. In this method it is used for those reagents which are readily absorbed from the leaf surface. So spray method is generally used for those label compound or radioactive tracer which can be readily absorbed from leaf surface. When it is applied in the form of spray on the leaf surface, they will get absorbed. For example, steroid. The plant is exposed to organic compound labeled with radioisotope. So the plant is exposed to the organic compound and it is labeled with radioisotopes for shorter period of time by using one of the above technique, and the biosynthesis occurs sequentially at each step and radioactive products are formed. These products are then isolated and identified. So in case of spray method, the spraying of the material radioactive isotope is done and these are readily absorbed from the leaf surface. An example is steroid. Now the plant which is exposed to the organic compound with it should be for shorter period of time, and the biosynthesis occurs sequentially. Now after introduction of radioactive isotope, the biosynthesis occurs sequentially. At each step, because radioactive isotope is inserted, so radioactive products are formed and these products are then isolated and identified. So all these are the different techniques for introduction of label compound or radioactive isotope into various plant parts to study or to elucidate the biosynthetic pathway and what are the different radioactive products are formed. They are isolated and they are identified. So this is about the introduction of label compound into the plant part. If you like my video, please press the like button and subscribe my channel. Thank you.